Hello guys, mga sanggay. Good afternoon. I'd like to do some tutorials with this problem on the friction applied on the ladder, as you can see in this figure. So let's read this one. This is a ladder weighing 185 Newton. You already have this in this figure. And then this is resting against a vertical wall. And then the top of the ladder, as you can see, is 12 meters from the ground. And then you have at the bottom make an angle of 60 degrees. So you have here this 60 degrees. This is 60 degrees. And then you have the coefficient of friction, static friction between the ladder and the horizontal ground is 0.35. So meaning here you have 0.35. And then you have with respect to the wall, coefficient of friction here is 0.25. Now aside from the weight of the ladder, there's the weight of the painter who is climbing this ladder at a certain distance s, which you are going to ask later. Okay, so the question is to compute for the s before it slips down, okay, before it starts to slide this ladder. So if we convert this one to Newton, multiply by 9.81 meter per second squared, this will give us a value in terms of Newton equivalent to around 646.8. So we can say 646.8 Newton. Okay, so this distance, by the way, okay, is just using this triangle. Okay, you have this triangle. Okay, I'm going to draw it here. This is 60. This is 12. If this is x, tangent of 60 is just opposite 12 over x. Therefore, using your calculator, we can compute x is equal to 6.93 meters. Okay, so we have here 6.93 meters. So this one is a normal reaction at A. This is frictional at A. And then you have also normal reaction. No, this one is frictional reaction at B. And then this is the normal reaction at B. Okay, so we know that here, let's say friction at A is just equal to 0.25, this one, which is the coefficient of friction at the wall, multiplied by Na. Here you have friction at B is 0.35, and then multiply it by normal reaction at B. Okay, so first is to come up with the forces along horizontal with sum of forces. All direction to the right would be equal to 0. So we have here 1 and then 2. So you have NA minus, this one is going to the left, you have FB equals to 0. Moving this negative FB to the right becomes positive. So you will have FB. But we know that FB is equal to 0.35 NB, right? So meaning we can have NA is equal to 0.35 NB. Okay? So, we can also say by mathematics, by dividing both sides of 0.35, if we divide this by 0.35, also this one by 0.35, we can have NB, just erase this one, okay, is equal to, cancel this one, we'll have NA, okay, over 0.35. Okay, so we have this value, and then the other one is this one again. I'll write it again. Na is equal to 0.35 NB. So we have these values and these values, which we are going to need this one in summing of forces at the moment. For summing of forces of or summing of the moment. Okay, so let's continue. So I just write here. Okay, now we sum up forces horizontal. No, vertical. Okay. The sum of forces vertical equals to 0. What are again our vertical forces? You have friction here at A, and then here you have normal at B. All the forces going up to be positive. Okay? So, what are the forces going up? First, FA, and then plus NB, and then this 185, which is going down, weight of the ladder, minus also this one, which we calculated or already earlier, which is equal to 646.8 Newton. Minus 646.8 Newton equals to 0. Okay, so we know that FA, as we have already identified earlier, is just equal to 0.25 NA. This is the one, okay? Okay. Hmm. Okay. And then NB, we can express NB as this one, NA over 0.35. So you can write NA over 0.35. Now, we can combine these two. We'll make it negative 831.8 equals to 0. You can notice that you have NA and NA. Okay, if we simplify this one in your calculator, you can solve NA equals to 267.56. Okay, 267.56 Newton. Okay, so we can also calculate NB actually, because NB is equal to, as you see here, NB is NA over 0.35. NA over 0.35. Substituting it will give you 267.56 divide 0.35. You can come up with your value of NB, which is supposedly it should be 764.5 Newton. Okay, these are so important when we are going to take moment, okay, at B to compute for the question of calculating S, which is the distance from B. Okay, so we have here, now again, this is NA and this is FB. Okay, now we take moment at B equals to 0. So NA is going in this direction, so meaning it is clockwise. Again, we already have the value of NA, which is 267.56. Okay, this is 267.56 Newton. So we can just have 267.56 Newton. Rotation here, and then the distance, which is perpendicular, is this one, 12 meters. Okay. Now what else? FA is in this direction. It's also clockwise. Okay. FA is actually, FA is equal to fraction. Okay, what is FA? It's 0.25 of NA. 0.25 of NA, which is 267.56. This is NA. Okay, this one is coefficient of friction. 0.25 of NA, which will give you, this one is 66.8 Newton. Now this FA is rotating in this clockwise direction, so that means it's also positive. That is 66.8. Okay, this is FA. Okay, multiply by this distance up to here. This is perpendicular. This is what we calculated earlier, which is 6.93 meters. Okay, and then what's next? How about this 185 going here? Okay, it's anti-clockwise. Actually, the distance here is just this one divide 2. 6.93 over 2. Okay, so that is minus because that is anti-clockwise. 185 multiplied by 6.93 over 2 is just 1/2. Okay, how about this painter? If I'm going to draw this one here, okay, This is the penter, which is 646.8 Newton. This is the distance S. This is 60 degrees. In other words, this one is just a cosine function. S cosine 60. Okay, so this one rotates in this direction, meaning that is anticlockwise will give you negative 646.8 multiplied by this distance. S cosine 60 degrees. Now, all of them equals to 0. This one, you can calculate this one. These are all numbers. Also this one. And then what remaining here is will be your S. Okay. So, you did with your calculator. I'd like you to use your calculator. It should be equal to 9.4 meters. Okay. So, that's all for this problem. If you have questions, you can drop it in the comments or you can just send email to me. Thank you and see you in my next tutorials.